Okay, this is going to be a very quick video on Bluetooth control for robotics. Been looking at a couple of apps online. For our Year 10 DT class, Mr. Titsos has been very interested in controlling robots using Bluetooth. So we'll have collision avoiding robots and Bluetooth robots, and he's quite graciously gone and purchased a Bluetooth control module called the HC06. So I'm going to very quickly give you a rundown on that particular addition to the robotics course. There's a couple of things you need to know about wiring it up so that you don't blow it up. So we'll be looking at that, and we'll be looking at two applications that control the Bluetooth. There will be the Arduino application, which is really an interesting application because it allows you to control all the IOs, the input and output pins on the actual Arduino microcontroller, and it also allows you to control them in an analog fashion and send and receive data as well. So if you were developing something that was going to use Bluetooth, or you wanted to control the Arduino using Bluetooth in a very controlled way, in lots of various ways, that would be the application you would use, Arduino. And I'll show you how that works in a very simple fashion in this video. And we're also going to be for controlling our robots using an application that actually has an interface on your phone or your Android device. It has to be Android, not iOS, which will allow you to control it using up and down arrows and that sort of thing, a more conventional application interface. So you'll be doing both of those. You'll be looking in the links below for the links or the link to this page on my robotics page. For more information, there'll be circuit diagrams there and other information that will supplement this video. So if you're watching this video on YouTube, I suggest that you also click on the link and visit the robotics page and the robotics site. It's a Google site. There's a lot of resources there that you'll be able to utilize that will be helpful if you're running a robotics course. It might take a little bit of the mystery out of the whole process. Back shortly. Okay, we're back again. This is at the moment my robot in complete disarray. As you can see, also, welcome to robot hell. I spent most of last night mucking around with this particular module. It's quite exciting about what you can actually get this thing to do. The possibilities, at least, are virtually endless. But as you can see, that little device there with the flashing LED, that is the HC06. And at the moment, we know it's not paired up, because when it's paired up, the firmware, which is the software on board that device, will make that LED come up constantly bright. So at the moment it's flashing, and that is our device. And I just thought we'd get to the sexy bit and see it actually operating, and then we'll actually we'll go through all the details to make it actually do something. But I just thought I'd show you. At the moment, as you can see, I've got a breadboard, and there's a little LED just there. Okay, see the LED off to the side here? That LED is the one we're going to get to switch on and off via Bluetooth using the Arduino app. And on my robotics page, as I said, you need to click on the link if you're not on the Google site. And in that on that page, obviously you'll find this video, but you'll also find all the videos that I've gotten to actually work all this out. This is what's known as active learning. It's something that we're very keen on at the high school that I work at. You want to learn something, you've got this magnificent resource called the internet with lots of different resources and people's ideas, and you need to be able to find the information that you need to solve your problem. I started this whole process with the problem of saying I need to, or we need to, as a department, the CAT department, need to make a robot that's going to be Bluetooth controlled. And like I was saying, Mr. Titsos has gone out and gotten the necessary device, which is the HC06, which you can see flashing before you. We're going to now get that to control that LED. The wonderful thing about this Arduino app, and I'll show you the interface in a moment, is that it allows you to control all of the inputs and outputs on your Arduino. So if I grab an Arduino, I'll just show you what that's all about. We've already, obviously, if you don't know what an Arduino is, on my robotics site, there's a whole page all about it. But the Arduino app allows you to control all of these inputs and outputs, and basically get the thing to do whatever you want it to do. So we'll just have a quick look at that interface now. We'll get my ancient Nexus 7 tablet, and we'll just see if we can make that a little bit clearer. Okay, so here we have our Nexus 7 desktop, and over here we have our Arduino icon. So we click on that, and it opens up Arduino. And as you can see down here at the bottom, in this bottom section here, and I'll put a link, like I said, on my page to show you the actual demonstration of this by the gentleman who developed it, because it's certainly going to teach you a lot more about it than I can show you in this short time. But you've got analog inputs and outputs that you can slide up and down. Okay, and I haven't tried to do that with the LED on this particular circuit that I've built. And then you can actually send and receive data in those boxes, which could be a very handy thing if you had an LCD screen attached to your Arduino. At the top here, these are the inputs and outputs, and as you can see, you've got all from 2 right through to 13. I think he's left 1 out because it's normally used for serial transmission of data. But as you can see, that's your interface. At the moment, we know we're not paired because the little LED on our HC6 is flashing, and so we know it's not paired. So what I'm going to do now is I'm going to show you on the interface how to actually pair the device, because I was going into the actual settings on my Nexus and getting absolutely nowhere. What you do is down here, you've got this little 3 dots here. You click on that, and it's going to say, when you click on it, hopefully, if it behaves itself, we've got a whole lot of menus down the bottom here, and one of them is make my Bluetooth discoverable, and the other one is connect. So if it's not discoverable, click on that, and it says, do you want to allow this app to do that? Do you want to allow it to make it discoverable Bluetooth? And we say allow, and then I'm going to click the 3 dots again, and I'm going to click on connect me. And when I click there, it says the HC06 is one of the Bluetooth devices, see HC06, that's available to pair with. So I'm going to click on that, and hopefully when I do that, it says unable to connect to device, which is pretty typical for Bluetooth and for a crappy system like I've got. So we're going to try again. Connect me to Bluetooth device, HC06. See if it does it this time. Connected. Okay, and we're going to see if I now go around to have a look at my HC06. Da-da! The light is on constantly, which means that the Bluetooth is operational and we are connected. So I'm now going to actually get my Bluetooth now to switch on and off an LED, and the LED is let's have a look here, hiding in here in amongst this bunch of wires. So there's an LED, and you won't see it until I switch it on. But what I'm going to do is I'm going to step back, I'm going to take the camera out of the cradle that it's in, and I'm going to show you how I'll probably dim the lights as well, and we'll see if we can get the light to switch on and off. So bear with me, and I'll be back with you shortly. Okay folks, I've had to dim the lights because the LED is not very bright, but as you can see, we're in our Arduino application, and as you can see there, we've got the digital right toggle on and off screen up here. And if I push number 13, if you can see in the background there, the little LED that you can now see on, I can toggle that on and off via Bluetooth. So that's happening completely wirelessly now, and it can happen at whatever Bluetooth range is. So I can do that from across the room, no problem at all. And as you can see, that is actually triggering on and off pin number 13, which is the LED. Now, pin 13 isn't an analog pin. It's it doesn't allow me to change it in an analog fashion. I'm going to make it slowly brighter and then slowly dimmer. So what I'm going to do is I'm going to switch now to that LED to pin 11, and we're just going to have a look at how down the bottom of our screen we have this wonderful provision of these sliders, and I'm going to use one of those to control the LED in an analog fashion. So bear with me, I'm just going to do a quick wiring change, and we'll have a look at how from pin 11 we can slide the brightness and make it slowly brighter and slowly dimmer. Okay, so now we've got our Arduino set up on pin 11, which is one of the pins that's available on the bottom of our Arduino app. I'm going to just dim the lights, and I'm just going to show you how this can change in an analog fashion. Okay, so we're now sitting in the dark, and what will happen is, if you look over here, as I slide that slider up, you'll notice that our LED, which is, you can't see it really brightly, but you'll see as I crank that up, our LED will get to full brightness, and you can see in the background now the LED that I'm talking about. And I'll just cover it so you can see it disappear, so you know what I'm talking about. That's the LED we're talking about, okay? And now if you keep your eye on that LED, as I crank the brightness back down again, it'll slowly get dimmer in a continuous fashion until it disappears. So we go brightness up, brighter, 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 and brightness down to 0. Brightness up. Now, this is what's known as an analog, which means it's just a fancy electronic term for changing in a continuous fashion, like when you turn the volume up on your radio, or when you've got a dimmer in your house and you want to dim the light. It doesn't switch off in an analog, in a digital fashion, which is just on and off. Digital state means it can only be on or off, fully on or fully off. So analog allows you continuous control, and this is allowing you continuous control. So isn't that a wonderful feature to have available? And obviously, if you wanted to add a lot of features to your robot, this would be a way of writing code and giving you complete control. And this Arduino app is also supported by the necessary Arduino code for the IDE. So it's very simple to set up. I'm now going to quickly show you a little bit of information about what's known as a voltage divider. Don't panic, it's just a way of wiring this up so you don't blow the inputs, because there's a couple of things you need to know about the inputs, which I will very, very quickly explain at the end of this video. And then we'll be probably ending the video there because it's going to be too long otherwise. And once that video is ended, the next video will be the actual creation of Bluetooth control on your robot chassis. Okay, so this will give you all the information you need to actually control the Bluetooth module and keep it all in one piece so the smoke doesn't come out of it. Because we all know that once the magic smoke comes out of the electronics equipment, it doesn't work anymore. Mr. Komodos learned that from years and years of destroying electronics over and over again. Bye! Okay, folks, this is the HC06, which is, how the magic happens. And as you can see, it's very, very well labelled on the back this particular device. You can get one that hasn't got the pin out or the breakout board on it. Make sure you get the one with the breakout board. It's got some protection on it. And also, God, I need to cut my fingernails. Also, school holidays. Also, it is very, very well labelled, and as you can see here, 4 pins on it. Sometimes it comes with 6, but this is with the 4 that you need. You've got the pin over this side is the voltage in, which it tells you can be anything from 3.6 to 6 volts. So I would suggest you just wire it up to the VCC on your Arduino, which is 5 volts. And leave it at that, rather than, there is a 3.3 volt pin on your Arduino, but that's too low because it's asking for 3.6, and that was one of the mistakes that I made at the start. And then the next pin up is the ground. Don't worry if you can't read these on here; they're all clearly labelled, and there will be a wiring diagram on the web page as well. And then you've got the transmit and the receive. The main thing to remember with transmit and receive is that if you're looking at your Arduino, and I'll just grab an Arduino here to show you, on your Arduino, on pins 0 and 1, you have transmit and receive. Now, what the counterintuitive thing about it's these pins, 2 pins down here. The counterintuitive thing about that is that transmit on your Arduino goes to the receive on the Bluetooth module. Okay, so transmit to receive and receive to transmit. Okay, so you because obviously whatever you transmit from this Arduino has to be received by this Bluetooth module. Now, obviously, when you transmit, it's going to be transmitting at a level of 3.3 volts for an on state and a 0, I think, for an off state, which the Arduino has no problems with. Okay, it'll respond to that as a 0 and a 1, no problem at all. So from this device, transmitting from the HC06, okay, the Bluetooth module, to the Arduino, we just wire it straight up. It can go straight from here, transmit, receive straight into the Arduino. The problem arises when you actually want to connect the transmit from our Arduino to the receive line on this HC06. So transmit to receive. So on the receive line for this HC06 Bluetooth module, it doesn't want to see above 3.3 volts or much above that. If you were to take the 5 volts from the Arduino and feed it straight in here, it probably will work. It might even work for quite a while, but at some point in time there's a good chance that you will blow up your input for this device, and you don't want to be doing that. So what we need to do is there's a couple of different ways of doing it. There's an electronic way of doing it. We can actually buy a chip that will convert the 5 volts down. That, if you're doing any high-speed communication, is probably a better method. But the very simple method is what's known as a voltage divider. And I'm going to quickly show you a little diagram to indicate what that is, because it's really probably the world's most simple circuit to build. To understand, probably takes a little bit of knowledge, but I'm going to try and explain it to you in a simple way, and that may help us out a little bit. Okay, so let's get started. A voltage divider. Basically what it is it's 2 resistors that will split up the voltage in an equal ratio. So if I was to draw my positive pin, so that's my positive, and we drew one big long resistor, and we come down to my negative pin. And just for argument's sake, we're going to make that 5 volts. Okay, so we've got 5 volts across that resistor. And if I was to take my trusty multimeter and I was to put it on onto volts, DC, and I put the positive lead up the top here, at the top of the resistor, and the negative lead down the bottom, it would read, lo and behold, obviously 5 volts, because you're across 5 volts, okay? So that all makes sense, I'm hoping. If it doesn't, you're going to have to really get into some basic circuit theory and Ohm's law and everything else. You know, if that was a battery output, and I put my positive lead here, and that was a battery negative lead, okay, go across here, I'm going to have 5 volts. Okay, so what the divider does is, now we're going to use a little bit of imagination, and we're going to imagine that we have a little sliding pin that can slide up and down along the length of that resistor. If it starts right at the top and we measure, we're still going to have 5 volts. But as we slide this little lever down, as we get to the halfway point, here, as we get to that halfway point, if we were to measure from here to the bottom, we would actually get 2.5 volts because we're halfway along here. And if we were to measure from here, the center, to the top, we would have another 2.5 volts. And that's what's known as a voltage divider. So if I wanted to make my output 2.5 volts, I slide this lever down to halfway, and if I measure from here to here, I get 2.5 volts. And if I measure from the top to the middle, I get 2.5 volts. And of course, 2.5 plus 2.5 gives us the total input to this divider. So if I want to, like I said, change the ratios, all I need to do is slide this to a different point on the resistor. Well, obviously, with our circuit, we're not going to use a sliding resistor. We're going to use what's known as a voltage divider, which works on the same principle. And I'm going to show you how that circuit looks like now. So we'll just flip this over, and we will. And I think I'm going to probably have to flip this video in my editing software so that you can actually see it the right way around and probably make more sense, I'm hoping. Okay, so with this circuit, what we do is same process. We've got plus a positive there. I'll just slide this back so you can see it. And then we're going to have two resistors in this circuit. That's number one. And these little wiggles are just the symbol for a resistor, in case you didn't know. Okay, and that's minus. Now, you need to pick the value of these resistors. So if they were too low, your 5 volts coming out of your Arduino will be pouring through these resistors, and you'd be losing a lot of energy from the battery. You basically need to have these in the ratio of 1:2, because you want to have roughly 2/3 here, okay, of the 5 volts to give you a little bit over 3 volts, 3.6 volts. So, or 3.3, sorry, volts. So, was it 3.3? I better not misquote. Yes, 3.3. So what we do is we need to have this in the ratio 1:2. So we could have a 1 ohm resistor there and a 2 ohm resistor there, but that's going to be really problematic because with just 3 ohms across your Arduino on your output pin, so this would be in the case of that circuit we were just looking at, the transmit pin from your Arduino is the positive, okay? That's the transmit pin, and it's generating either 0 volts or 5 volts for a 1 when it's switched on. And obviously when it's switched on we see 5 volts coming in here, and if we were to feed that straight into the receive line on our HC06, and I'll just draw our HC06 over here, HC06. If we were to feed that straight into the receive pin on our HC06, big problem, because 5 volts straight in, kaplooey. Okay, so if I was to, and this is our ground pin, GND, and that would go to the ground. So if I was to, we'll just hook it up there. If I was to connect that straight into the 5 volts, problem. It's going to probably over time blow up my HC06 Bluetooth module. So what I need to do is I need to create a voltage divider, and instead of having a 1 ohm and a 2 ohm, which is going to draw too much current, and remember we have, I think it's a 40 milliamp limit on the outputs, that's going to blow up my Arduino using that voltage divider. So what I've used for my values, get rid of those, I've used 10K, 10 kilo ohms, 10,000 ohms, and 20 kilo ohms. And what that does is, we get, if I was to measure, I'll just grab my meter to show you where I'd be measuring. If I was to measure across this resistor at the top here, the 10 ohm, from here to here, okay, I would have about 1/3 of the voltage, which I don't want. That would be too low. 1/3 of 5 volts is going to be too low. So what I need to do is I measure from here to here, okay, from the top of the 20 kilo ohm to the bottom, to the negative rail, or negative, or to ground, and that will give me my 3.6 3 volt output that I require. So what we do is, instead of wiring it to here, to the top here, okay, I'm not going to do that, we're going to take it and we're going to wire it to here. And da-da, that is a voltage divider, okay? We now have, across these 2 pins here, if I put a little voltmeter, okay, it's going to measure 3.3 volts, or thereabouts. And if I was to measure from here to here, it's going to be the full 5 volts. That is a voltage divider. Hope that's helped in some way. If that's really, really confusing for you, don't worry. I will have on the website, so click on the link if you're watching this in YouTube below. I'll have on the website a proper circuit diagram to show you how to wire up the HC06 so that you don't blow it up, hopefully. Just remember, with anything that I do, all care but zero responsibility. Thank you. So that is how to wire up your HC06, how to use a voltage divider, all that sort of stuff. That's going to be the end of this video, and like I said, the next video on this page will be how to actually build your chassis. I'm going to make it a fairly short video because the actual details about how to connect the motor shield and how to build this chassis is on my robotics page. So building the chassis, there's a whole instructional series on how to build the obstacle avoiding robot. So if you have any problems with the actual construction of the chassis or how to connect the motor shield, that is where you're going to find the information you need to actually be able to do that. There's no point in me making another, half-hour video because half the time people are too time poor to watch the entire thing anyway. So if you're coming across any problems, go to that site. You'll be able to find the solution to your problem. And yeah, we'll leave it there. And yep, next video will be hopefully a working Bluetooth controlled robotic chassis. Bye.